Hey, gang, this calculus lesson is it's part one of the fundamental theorem of calculus, and we'll just go ahead and get started with it here. So for the function f continuous on a closed interval a, b with capital F, the antiderivative of the function f, then the integral from a to b of f of x dx is the antiderivative f of x from b to a. And once you get your antiderivative, then you plug in b first and you plug in a second and you subtract those two. Okay, so notice if there's no numbers right there, then it's called an indefinite integral, so that's where the plus c comes on right there. And when you have numbers there, it's called a definite integral. Okay, just some notations there. All right, so let's go ahead and evaluate some of these. Evaluate the definite integrals here, okay? All right, so what I'm going to do is integrate this, so add an exponent and divide by it. So this is going to be x to the third divided by 3, and this is going to be minus 3x. And so now I'm going to plug in x equals 2 right here and right here. Whoops, there should be a fraction bar right there. And then subtract x equal 1 right here and right here. So I'm going to go ahead and plug in 2. And so when I plugged in 2, I get 8 thirds minus 6. And when I plug in 1, I get 1 third minus 3. And then we subtract those two quantities, and I end up getting negative 2 thirds. Alrighty? Piece of cake, huh? Alright, so here we go. The integral from 1 to 4 of 3 root x. Okay, so I'm going to make it 3x to the 1 half. And then when I add 1, it becomes 3 halves. And so you divide by 3 halves. And check it out, you guys, when I invert and multiply it, you know, when you have a fraction in the denominator, it inverts and gets multiplied, so it's actually 2 thirds, and the 3's are going to cancel. So it becomes 2x to the 3 halves. And then now I'm going to plug in 4, and then plug in 1, and subtract those two. So I left the 2 on the outside right there when I plugged in 4. Now 4 to the 3 halves is the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8. And then this is 1 right here, and then so I end up getting 14 on that. All right, and then so here the integral of from 0 to pi over 2 of secant squared. Remember, the integral of secant squared is tangent of x. So you're going to do plug in tangent of pi over 4 minus tangent of 0. Tangent of pi over 4 is 1. Tangent of 0 is 0, so you get 1 on that right there. See, this is easy, huh? All right, absolute value function right here. Okay, so remember, absolute value functions, they graph v's, you guys. So what you got to do is find out where the vertex of that v is. So you set the inside part equal to 0, and you find out that x equals 1 half is where the vertex of that v is. So you break it up right there. So if we graphed it right here, so here's the vertex at x equals a half right there, and there's the v going right there. This is negative 2x minus 1, and then this one's the positive 2x minus 1. So we're going to go from 0 to 1 half, x equals 0 to a half right here, and then from 1 half all the way up to 2 right here. So let me get a better picture of that right there. So it'd be that picture right there. Okay, and then here's the math right here. Okay, so add an exponent, divide by the exponents, and I get that. And then you're going to plug in here, I'm going to plug in a half first, and then plug in 0. And then here I'm going to plug in 2, and then plug in a half, and subtract them. And as long as I did the math right, I get 5 halves. Alrighty, let's see, what else? Okay, find the area of the region bounded by, BDB means bounded by y equals 2x squared minus 3x plus 2, that parabola. The x-axis, x equals 0, and x equals 2. Okay, so here's that right there, and then here's x equals 0, here's x equals 2, and then here's that parabola kind of sort of right there. All right, so we're going to go ahead and add an exponent, which is 3, and divide by the exponent, which is 3, and add an exponent, divide by the exponent, and so on, going from 0 to 2. Okay, so the area of that region ends up becoming 10 thirds. All right, second half is coming up on the Fundamental Theorem of Calculus, and oh boy, can't you wait. Okay, if you're in my class, that would be your homework assignment.